just starting it.
Oh, yeah, okay.
It's okay. It's distributing, but you are going to use it like afterwards. It's okay. Depends on which version of Civil 3D you have. Okay, let's open the drawing without profile. Where did the vertical lining from?
In the soup. The liquid eye.
For now, we can open the normal, but for the corridor, you have to go to the other and I will show you the styles which are there.
Okay, I'm supposed to do this.
It's fine. Well, you open it in the UK kit. If you haven't installed, you can open the also 3D.
When opening the
Okay. So let's select our profile, the design profile. Then you go to edit, profile labels. Then we are going to use the default labels for Civil 3D. These ones you can customize them afterwards. So all there.
edit profile style.
Select the profile,
Yes.
then you go to edit profile labels. So on the extreme left, so click on it. Then you are going to import the default label styles from Civil 3D. So you select import label set. Then in the drop down there is no labels, then complete label set. So you select this option, you press OK. So it has the types of labels. It's going to give us labels for the lines. Those are the tangents, which has the grids, then the grid breaks, then the labels for both the curve, the crests and the sag curves. So you press OK. So these are default labels for Civil 3D. We're going to use these ones for the training. Then you can, I think Edward will take them through customizing these labels. So if we go back to our table, from the geometric design manual. The minimum grade in both cut and fill is 0.5%. This is basically for drainage purposes. A slope less than 0.5 may cause ponding of water on the road, so you have to be at least 0.5 or above for the slope. So you are going to make sure our slope is above 0.5%. And then if a class, so this is a class 3 paved, we go to a class 2 paved, I think, which is this one here, one up, still 0.5. Then you are going to look at variables such as the K-mean, that is for the stopping side distance, for the sag and the crest. So for the crest, the K-mean is, so if you look at the profile of our road, it is basically a rolling terrain. By just like observing it, but if you check with the grades, you can confirm with the grades the difference in the grades for both the grade in and the grade out of the existing ground. So basically it's a rolling terrain. So we are going to consider the variables in this row here, this column here. So for the stopping, the K-mean for stopping for the crest, it is 22. Then for the sag is 20. So this, we are going to look at this where we are making our vertical profiles for both the curves, for the sags and the crests. So if you look at these labels here, if you look at these labels, there is a point, the highest point is at the station at the highest point, then the elevation at the highest point. This is basically at this point here. This point here gives you the coordinates, then the chainage, the elevation. So the coordinates are not there. Then the stations for the point of intersection, that's the PI. Then the K value. Then the vertical curve length, LVC. This is vertical curve length. So if you have to go through our profile briefly, we can see our grades are, some are not meeting the standard. This is 0.18%. And some grades are so close to one another. So we have to space to create our profile so that the road is smooth, so it doesn't have bumps as you're driving through the road. So we are going to edit all this. Then also we have to make sure our low points are not below the existing ground. That is basically still for drainage purposes. Then also we are going to assume some points have culverts. So we shall add some fill at those points. Now for example, this is a swamp here. So on ground they constructed some box culverts at this point here. It floods when rainy season, so we have to add some fill here for drainage. So we are going to start by removing some IPs and also adjusting others. So we select our profile, then you go to geometry editor, this option here, the modify profile panel, go to geometry editor. So we are going to use this. So we are going to delete some PIs. Then we adjust the curves we have. So we shall use this option here, delete VIP, that is for deleting the points of intersection for the grades, the tangents. Okay. Shall begin with this one here. Idea is not necessary. Then this one here. So let's go on. As we work, we delete the IPs which are so close to one another, and after we adjust the location of the IPs which should be left. so that we get an ideal slopes on throughout the road. We are going to okay. So we are going to assume we shall have a culvert at this point here. So I begin adjusting the IPs which are left. So in this case, at the low point, I'm going to adjust the. I'll drag this midpoint of the curve, this round bit. I'll drag it above the existing ground. So we are assuming at this point we are going to have, say, a 900mm culvert. So our fill or cut, our fill, at least that would be greater than 3/4 the size of the culvert. Which at least more than 0.8 meters at this point at least. So if you check in the tab for fill, it is still small, I think. This is for cut. So 0.91 at this point. Can I just still further? Let's do this curve here. You can actually edit the values of this curve length from this point here. If you click on this icon here, you try to make sure the values of your curve length are in round numbers. So this one is, let me see. This is 392.915. You can round it off up to like 400. Then this one you can round it off to. So you can round it off like 100. Try to have round figures. Can you all see this tab here? You have been adjusting the values of the curve length, profile curve length to round figures. Those are which you have adjusted so far. So as you adjust the length of the vertical curve, the curve value also changes. Since it's a function of the vertical curve length, the curve value. If you click on this icon here for editing the profile layout, this icon which is called profile grid view, it will bring you this dialog here where you can edit the length, the vertical curve length. So remove this also, it's not necessary. So I'm going to first go through the entire road, editing removing the PIs which are not necessary, and also adjusting the vertical curve length, and also the grids. Make sure they meet the standards. You also have to make sure your vertical curves do not touch each other. Make sure they don't touch. The curve is what I'm trying to do. I did some PIs.
Is what you're doing?
Yes. Adjusting the curve length. At times what just to meet the standard, that's the curve value. Now for a class 3 paved road, the minimum curve value for a crest curve is 22. That's for a rolling terrain. Then 20 for the sag curve. Yeah.
So in case I find the length at 64, what do I do?
The length is what?
I'm seeing the length is 64.
Then you try to, maybe you have some PIs which are close to one another, and you have to delete maybe one and you adjust the curve until you get an ideal curve, ideal profile. Then also, since it's a town road, you try to make sure you keep more or less on the existing ground, so that you don't overfill. It may cause problems with access to properties along the road. So make sure you minimize your cut and fill.
So not before because I've been installing the software.
Okay, basically what we are trying to do, we are trying to redesign our vertical profile so that we meet the parameters of a class 2 paved road for a rolling terrain. And the parameters are basically looking at the minimum curve value for sag, which is 20, and also for the crest, which is 22.
Can you show us examples of those, how you see them like
Oh, no.
on the design? Where you see
I'm going to show you. So we basically look at the K-mean for the crest and exact curves, and also the minimum grade, which is 0.5. So if you select your curve, your vertical profile, you select edit add profile labels. So I selected the option of using the default labels for Civil 3D. So I selected import label set, then I selected complete label set. It's okay. So when you close, it's supposed to bring you something like this. So now basically now for this curve, can see our minimum K values for the crest is at this point is 67.17, which is a function of the vertical curve length. So if your K value is below the minimum, you adjust your vertical curve length until it meets at least above the minimum value.
So what if those things are missing like on the curve? They are only one bit. Or how do you
Ideally, if you select this option of edit,
Yes.
it's supposed to add on all vertical curves on your profile. Just slightly. Note what other parameter we have to look at is the maximum grade for that type of road, which is maximum grade desirable is supposed to be 5.5, but the absolute maximum is supposed to be 7.5. You just have to look out for that. So this area is a swamp, so you have to provide enough fill for the box culvert. So let's assume the culvert, the level at the bottom of the crossing stream, let's say is half a meter from this point, from the existing ground as picked by the surveyors. So we add an extra, say 1 meter on top of 1 meter fill on top of the culvert. So make sure as we pass through the swamp, we have at least a meter fill. It's just an example. And also make sure the cross slope is at least 0.5 or above. So if I check on the band for cut and fill, you design as you check the values for fill at this point. The values for fill are supposed to be positive, and then for cut, negative. So try to balance to make sure I have enough fill in this swamp. I'll add another PI, say in the center of the swamp, like at this point. Then I try to achieve my minimum slope of 0.5%. So the easiest way to do it is to come to this icon here. Then I check the values for the cross slope, which are here. I use this icon here, add a new PI. I just selected a point somewhere in the middle of this one. So the slopes at this point are 0.33% and 0.23%. So I'll adjust them until at least they are 0.5% and above.
According to our profile, where where is indicated less than 0.5, we have to adjust.
Yes, at least it's more than 0.5%.
In the areas of the swamp.
Even in the swamp region, that's why I'm adjusting, but even in other areas of the road, it just would be more than 0.5%.
In areas of fill,
whether in fill or in cut, it just would be more than 0.5%.
For culvert locations.
That is for drainage.
Drainage.
Yeah, it's the minimum slope.
Minimum slope. How about areas of culvert?
There we are trying to increase the fill, because according to the standard, there is a minimum fill. It's supposed to be placed above the culvert, which is 3/4 the size of the culvert. For a 900 millimeter culvert, we are considering something like 800 millimeters above the culvert. That is excluding the size of the pavement. It has to be up the formation level. If it is less than that, then the culvert will have to be encased. Yes. Six.
It's what you do. Yeah, because it's better to even switch off your snap notifications.
I'm sorry, I have to come here, but I'm not understanding what you're doing.
I'm trying to smoothen our vertical profile because if it is having many curves along the length, it will be having bumps along the road. So I'm trying always to create a smooth profile. Yeah, and also trying to provide for canvas. Now this is a pillow point. By trying to provide for a what like enough feel for the canvas.
So how did you put a culvert? How did you?
No, I'm more or less like increasing the feel
Yeah, it's this thing.
in the swamp region. You get it? Okay, let me just go back and explain it again. So anyway, what I did from this side, you can say reduce the number of PIs on this side. So get to reducing the number of PIs and also make sure minimum slope.
The number of people.
PIs, the points of intersection.
Those points there.
Let me show you. Now when you see such whatever, this is a PI point of intersection where two tangents meet. Yeah. Then make sure the curves don't touch your minimum slope is more than 0.5%, whether negative or positive.
Because the lowest is 0.5.
Yeah, that is for drainage.
0.
Yeah. So always I trying to create a smooth curve, not with many APs as well.
So where we have percentages, you keep adjusting more
Until you
than
get
your percentage.
it's more than 0.5, it adjusts automatically. Maximum grade is
maximum percentage.
the absolute maximum is 7.5. You don't have to go beyond this. Then the maximum, the variable is 5.5.
But I've seen you with 9 point something.
still adjusting. I'm going to correct that. Yeah,
So no negatives.
even negative is fine. That is
Should be plus or minus
Yeah.
5.
0.5% here.
Okay. Then I would like to know how you can put a caveat, like you put a provision of a caveat.
That is increase the fill. So now in this region, and I'm going to explain this basically. Yeah.
I want to know this area by satellite.
Yeah. At this point, so you select that, then you select where you want to insert it. Yeah, you can click, then it will be added automatically. Unless there's a curve which is overlapping. So there's a curve which is overlapping. That is why it can't be inserted.
On the satellite.
So you just try to adjust this one which you already have rather than inserting. There's a curve which is still maybe you see this one is stopping the levels up to there. Just select the curve itself. I mean the vertical profile, then you adjust using the PA, that whatever at center one, that one. Or either of the three. It's like bring it towards us if you do that one.
Just as before.
That's the minute.
Just think of yeah.
Once you complete start moving up. That what you can do, you can first do the curvature.
Azindalo kalina kokubiri.
I know that one. After just appear alone. So there was another curve here which you didn't see. So it was confusing.
That's what I'm asking.
And now just adjust this one here. So reject this to make sure you curves do not overlap. You can see like where you curve in there. Make sure it doesn't overlap with another curve.
Yeah, that's what
Hello, attention.
Something like that. You can now add the
Attention.
curves. You adjust this at it's more than 0.5%. Then you can come here.
I think I've been disputing the kit. Unfortunately, for those that didn't have the kit installed initially, were having problems opening just like I instructed, okay? So I realized that some people haven't yet actually dropped anything ever since the beginning of these illustrations. Okay? So, for those that have understood, good enough. I know some of you have different queries, some of them from the start, some of them it's maybe midway. So I'm going to be moving the microphone so that maybe he's going to give us the next 30 minutes, try to explain what he has done, okay? So maybe I will start from one of these sides. If I speak his attention.
I just want to make it something that's more than 0.5. You can just delete one and you modify using what is actually available.
I need 0.5.
0.5. Can actually remove this one then can remove this one. Then maybe adjust.
That's a question.
Can I adjust this one? It's okay. Adjust this one. And make sure the feed is not so high. You can keep adjusting until you get 0.5 here. You can adjust from here actually. That gives you a picture of how you can do it from here. Just what you need. And just now the PI, make sure it is not so the ground. Actually, that is actually not supposed to be what you can delete this. And you add the PI which is slightly above the ground.
People have questions.
Okay,
So even him, you can actually, some people have the same. That's why you address it. And if why you done with the illustration of the demonstration?
I was going through the entire alignment, the protocol.
Okay. Let's fast forward to this. Go through about 20 minutes before we proceed. All right. So here's our attention. So with those with questions, please raise up your hands. We start with Paul.
Yeah, for me, like, I wasn't able to like, I would study so from the beginning,
So they're asking if there's a possibility of running through again, because some people actually have just installed that right now. So you could use a few of these minutes, go through again, then catch up with the rest.
Okay, we are going to go through the profile again from where I began from. It's okay.
How do I add another curve?
Another PI.
If I've deleted something by mistake and I want to replace the curves, either some curve or rest.
You can, if it's a you have inserted an API, you can use this to delete it. This third icon. It's the third icon here. Delete VIP. You select it and you click close to the PI where it is located. It will delete it.
How do I place the curve?
A curve in between new PIs. There is this option for this drop down. I think the default curve you see is this one here for drawing a fixed parabola by 3 points. So you select on the drop down, then you select free vertical curve in brackets parabola. It's the one you use. Then after you select your first tangent followed by the second. It's the same way we're doing for the horizontal alignment. So it's the same procedure. Then after you insert you can either use a K value, the vertical curve length, or the vertical curve length. You can use, if you know a K value, you can work for that point. You insert the K value, or you insert the vertical curve length. So I think let me just begin from here in the swamp, then we proceed up to the end. I think it's better.
Someone asked. Some engineer asked if, for example, sometimes you can have different classifications of the road, right? You have mountainous, rolling, and flat in the same profile. How do you go about that?
For each section, you apply the parameters for the different type of terrain. Maybe basically for a short road, you can compromise with the largest region. If it's more in a rolling terrain, you apply the parameters for a rolling. But if it's a long road, maybe 100 kilometers plus or even 70, you can separate your road into those three sections, and you design each section according to the parameters for that type of terrain. So I think for this For this swamp, we may remove the PI. I think the best option is remove the PI and raise the rod. Then we shall bank the rod towards one side. Because if we are to achieve the 0.5% either side, we may have a very high fill. So the better option is to have maybe a less slope and then we bank the rod towards one side. I think it's the same option we applied for this swamp. We had a less slope, then we bank the rod towards one side. So side. So we remove this PI and raise the vertical profile slightly. Then we shall in this region we shall bank the rod on one side. So I'll adjust using this icon here. I raise it slightly. So you can see our fill is, so I reduce this until it is like 1.5 throughout. So in this case we are having a design departure and the remediation measure here is to bank the rod on one side so that the water can flow off the rod. So we are going to use a slope which is less than the standard, but when in this region we shall use our assembly and the banking towards one side. So I go through the road from here to the end while adjusting the PIs and the vertical curves. So I go adjusting my cross slopes until I have something about 0.5%. In the region we are going to have something less is in the swamp.
We are changing the grade.
Yeah, with that's in the grid. The above 0.5%. Also adjust the curves afterwards. We have round figure.
The curves also.
I try to make sure I have at least try to have round figures for curves.
If you look at the demarcation there.
Since a town road, I'm trying to make sure I'm above, not so much above the existing road, maybe in the swamp alone.
Somewhere there. See this.
Make sure roller points are above the existing ground. That is for the low points. But for the sags, that should be above the existing ground.
with any queries at this area? Are we all at the same point? We all at testing the profile.
Probably when we discover that where areas where I see negative already, it's like they are not adjusted.
That happens in a case where your PIs are so close to one another and you have to delete at least one of the PIs. If you find you can't adjust your vertical curve, there must be two PIs which are very close to one another.
Okay, will you try illustrate how to do it?
So let me first. I'm going to show.
First finish.
So if you want to delete one PI, you use this icon and select close to the PI you want to delete, and then you click it to delete it automatically. If it is still refusing to delete it, you use this icon here, and you first delete your vertical curve. That vertical curve at that point. So I'm deleting this one. I select it to delete it automatically. And if there's a PI close, you will select it and you delete it using this icon. Then after you insert your vertical curve again using this drop down, select a free vertical curve, the parabola type, then you insert your new curve again.
How do you adjust the maximum rate and breadth?
You adjust the PIs. More or less adjust the PIs and also list some PIs which are close to one another.
It's about maximum grade.
Maximum or minimum.
You click enter.
Yeah. Okay. We're going up to the end. And I've reached. Wait.
What happened to my drawing?
I have an idea. I'm using this one here. Alignment. This one you've been using more. This one illustration is
I've been using this one. Remember, when did you try it so that these values also come here?
I'm going to replace what is here.
So that
Then one other thing at the end, at the extreme end, if you check our alignment, it is joining a main road, Metiana road. So when we shall be doing junction design, we shall have to adjust the profile so that the elevation at this point matches the elevation of Metiana road. We shall do a rough design of Metiana road at this junction here. So we'll make sure the elevation at the center line of Metiana road will be matching the elevation at the end of our alignment. That is for junction tying. Leave it like that. So what I can do, I'm going to just take this left side and I match it. And I
yeah, remember that.
just match the entire. On.
You're done.
Yeah.
Let me ask questions. Okay, he has reached at the end point of the profile design. I don't know if everyone has reached that side. If there is any more queries, please ask before we move on to the next item. My assumption that everyone has understood, perhaps you have any you ask.
Is lost.
Where should we start from the beginning?
Exactly where exactly are you lost from?
Because I didn't start like when you studied because I mean like now it's kind of makes sense to just somewhere so that way like I should follow from the beginning.
Okay.
You first ask if he has these great markings. If he doesn't have them, first add before you start addressing.
Do you have these labels, the profile labels?
As in, when you
Let me
take
just
the
go. So, if you have this design menu, you go to page 56, I think, page 46, table for 5. We are considering these parameters: absolute maximum grade 7.5, the desirable maximum desirable slope is 5.5. Then they came in, the minimum K value is 22 for the crest and 20 for the sag. Those are the parameters we look out for designing the vertical profile. Then to smoothen your vertical curve, the vertical profile, you make sure you go on deleting curve the PIs using this icon here, which are close to one another. At least make sure they're spaced out properly. Then after inserting your vertical curves, if you have put your tangents, you insert your vertical curves using this from this drop down. Then you select free vertical curve, parabola type, this type here. Then you use the same method you use for the horizontal alignment. You set your first tangent followed by the second one. Then you either specify your K value or the vertical curve length. They are all interrelated. If you increase one, the other one also increases. One is a function of the other. Basically for side distances. If it is below the minimum K value, that means you also have issues with side distances on the vertical and on the sags and the crests. So that's why you make sure you're above the minimum K value. If it is below and there is nothing much you can do, that's where you have what we call a design departure. And then you provide remedial measures such as maybe signs for reducing speed, also speed humps, and also maybe the chevron curve, chevron road signs. When you find them on the road, you find maybe it is a very sharp curve and there is what we call design departure. So you insert them on the vertical curve. Is a vertical curve message is reduce speed, or they provide road humps to slow down the traffic. If it's an horizontal curve, they provide road signage still for sharp curve, the chevron signs, both in the inside and outside of the curve, and also the speed signs. Then also inside the road humps. So that is why we look at all these parameters while we're doing a vertical profile. So you keep on adjusting, you make sure your points are not below the existing ground. Then your minimum slope is more than 0.5%, whether negative or positive. Then, and places where you anticipate you are going to have culverts, that is after the hydrologist does the design and the sizing of the culverts. It gives you the different locations. Then you adjust your profile to make sure you accommodate the culverts. If you can't achieve the minimum fill above the culvert, either you either encase the culvert, you encase the culvert actually. That is for it. These round culverts. Culvert, if the fill is not enough, you make sure your slab, the top slab of the culvert is thick enough to accommodate that traffic loads. That is why we provide for fill. So here in the swamp, we try to adjust the profile to make sure it is about 0.5%, but it was creating high fill values. So we decided to have a slope which is less than 0.5%, but in this area we are going to back the road towards one side so the water can be able to flow off the road. I think it's clear here. So we do that throughout the entire road in the vertical profile, following all those parameters. I think it's clear.
Excuse me. You're saying something about the design profile not being below the existing profile in the areas of site.
Yeah, that is in the raw areas. If it is in cut, it is fine, but in the raw areas, you have to make sure it is above the existing ground. Because if you cut in a raw area, the water will be stagnant in that area. You have to make sure it is above so it can be able to drain off the road.
So like in a swamp.
In the swamp, you have to make sure you are above. By all means, you have to make sure you are above.
I have a question about when I try to insert the minimum in the sub, does not save it.
It does not what?
Does not accept it.
That means because the K value is a function of the vertical curve. So if the vertical curve can't fit in that between those tangents, it will not accept it. So you have to adjust the location of your PIs until you can get a curve that can give you a K value which is above the minimum.
Thank you.
Physical, like how like to modify, like only a copy projector.
Agize wanaendelea for restart. Just a minute, let me first finish something here. Have a mouse. I'm trying to use this, but it's fine.
At which tones?
So good. This is the swamp. Okay, make sure for the swamp we are ignored the minimum, so inside it remains like the ground. We shall just bank the road on one side. And if it is less than 0.5, it's fine. We shall just bank it on one side. And the water can still flow off the road. And not something like this. This is appearing because some places we made your surface, that is why it's having these gaps here. Because they're supposed to be clipped and they what? There's no ground here. And painted with no made your surface fine. So to adjust whatever, you can use this. You can use it as IPs, you adjust the way if you want to do something. Keep on adjusting using this. If there are small flaws, you use this icon. You select near the PI, you delete it, and adjust until you get. So here you set your curve to that. Set your curve. So here you do adjust this until you get 0.5. You can adjust until you get a 90. Okay. If you see what you're trying to do, can't you adjust for what you have until you get exactly something which can work. Yeah. Just the case of this.
What happens when the API refuses to delete?
You first delete the whatever. You first delete the vertical curve. Then you adjust your PI. Then if you depends which closer one is always touching the curve. It's a first you first delete the curve. And after if the PI is close, they delete it or they adjust the position.
You say that out loud. Probably means that every point of that class.
I'm trying to match this one with this. But, what is what you are doing to me?
I can see your food went.
Man, I'm saying I've not even eaten. Wait.
You can start squat.
Where is this starting point? It's like they reverse this thing in this drawing.
Yeah.
Anyway, what to do?
Any question? I have a question.
I just want to understand, when you talk of banking the road and so on, does it mean it's elevating it?
Yes.
It's elevating.
No, normal crossfall is a normal crossfall from the standard is 2.5% either side, both on the left and on the right hand side. So in this case, in one case it's 2.5% positive, another is negative 2.5%. So if it is negative 2.5% either side, so if you have to bank a road on one side, we make one positive, so it becomes one slope throughout it. You shall see this with the assembly. You're doing the assembly.
And that is I think that is full spider version. Right? Yeah. What is the purpose? Drainage.
Yeah, drainage purposes.
Drainage purposes.
Let me first take another question. whatever. I'm just trying to create my whatever. These are just
Converting it. Human. Just be that.
yeah, but yeah. So you just have to match this. This point here. And I match. Where's our whatever? Uses this side.
I think that is my drawing.
Ah, sorry. Okay.
Why don't you just do it?
I just use this one.
Yes, you
Okay.
continue.
Okay.
Apologies.
Supposed to see this matrix.
You good?
Yeah.
Are we done with that?
So done. Just a minute.
Who have made progress on the final design? Do you all have something that is similar to the final design? If I'm to come and check each person's grading, are they within the minimum or the design parameters? Especially for our grade. Or we are still trying to adjust? So excuse him, he used a different drawing than I was using, that's why. But for you can equally still use the same drawing, make the adjustments. If you're to be keen enough, you will identify that actually your values for the vertical and horizontal geometry, they keep changing because they are dynamic objects. They are able to change and adjust.
Just leave this one here. Just start building the junction design.
Once we're done,
Yeah. I think, have you all finished adjusting your vertical profile? Yeah, I think
can you say why was it very essential for us to install the equipment?
because we're going to now redo the what? The corridor. Using the UK kit plans so whatever styles you can still customize further. So can we continue to creating corridors? Okay. So we shall open a new drawing. Then you still use data shortcuts. We should cut from the So we shall create a shortcuts for our profile, so we don't have to actually move with alignment to the new drawing. So still we shall come to the prospector tab on the tool space bar. We come to data shortcuts. Then you right click, set a working folder. Still this one. Then we set our data shortcuts folder using this option here. Then afterwards, we link the project with the current drawing. Check the project current drawing. Press OK. Then afterwards, we create data shortcuts. So we are going to create shortcuts for our alignment. We shall only select the option for the design profile. In this case, it is vertical alignment, so they named it. Then you press OK. Then afterwards, you can close this drawing and open a new drawing. Okay. You go to the tool space bar, click on it. Then you go to the prospector tab. Then afterwards, you scroll down to the data shortcuts. Data shortcuts icon here. Then you right click on it. Set your working folder. Then you select the same folder where you stored your survey, the shortcuts for your survey file with survey data, the surface. You select folder. Afterwards, you set your shortcuts project folder. Then you associate the project with the current drawing. Then afterwards, you select create data shortcuts. Then you select on the centerline alignment. On the profiles, you only select the vertical and the design profile alone. Then afterwards, you press OK. Then you can close this drawing. Then you open a new drawing using the UK kit.
The folder was submitted.
The working folder. The working folder used for your surface. You create data shortcuts. After associating the current drawing, you right click and select create data shortcuts. And afterwards, you can save and you close. Then you open a new drawing using the UK kit. Which version of Sport 3 did you have? 2020. Flash. It's going to give it to you.
You don't have? The whole table doesn't have. It's going to carry on, but just speaking. It's going to be installing. While it's done, it's going to catch up.
So we save our new drawing as design corridor. First we set our coordinate systems. From drawing utilities, then drawing settings. On the units and zone tab.
I wanted to ask when you created the data shortcuts, did you also check the corridor?
But you haven't created, you ignore the option for corridor. Yes, because we're going to create a new one. Yeah. So in the drop down, you look for Uganda. And since this road is in the northern hemisphere, it's above the equator, we go for 36 north. Then you press OK. Then we create references of our total shortcuts in this file. Still got the tool space bar. On the prospector tab, we right click. First set our working folder. We select the same folder we selected for the alignment and for the surface. We set our data shortcuts project folder. Then after we associate the project with the current drawing. Then on the surfaces tab, below the data shortcuts, there's an option for surfaces and alignments. On the plus sign for surfaces, you click on it. Then on the drop down, you'll see Mitiana existing ground. So we create a reference, right click and click on create reference. So for the style, we shall just set it to border only. On this option here for style, the default is triangulation. So on, if you click on that whatever the word triangulation on the extreme end, there are those three dots. You click on them.
I request you begin from after saving.
Some of us don't have that median surface.
It depends on whichever name you give them, give to the surface.
Shall have any plus sign?
You open the drawing in which you created your surface.
Template.
Yeah.
Template. Like a new drawing. Like after obviously like when you make new drawing. New template.
Template, as in if for the UK since they use the metric values, they use metric system, so it is the default water settings are in the metric, so you don't have to change anything. So you just use their kit. They use the metric system in the UK.
I use the metric.
It is already the default settings for the UK kit is the metric system. So those who have questions is going to be helping you out. Okay, let me go back there. In the new drawing, you go to drawing settings, drawing utilities, then drawing settings. You set your coordinate system, come on the drop down, you click on it, you type U to take you straight to Uganda. Then afterwards, the coordinate system, since the road is the northern hemisphere, you will go for 36 north. Let me press OK. Then you import your data shortcuts for both the surface and the alignment. you got the tool space bar, you click on it. Then on the prospector tab, there is an option for data shortcuts. When you scroll down, you right click on that icon for data shortcuts to bring this dialog. You first set your working folder, then you set your data shortcuts project folder. Then after, you associate the project with the current drawing. Then afterwards, there's a dialog for surfaces and alignment. There are two whatever options. You can shortcut many things, even the code you can shortcut it, assemblies, and you can shortcut many things. So in this case, we are going to create shortcuts for our surface and the alignments. So on the drop down for the surface, you click on the plus sign, and in this case, we had created data shortcuts for the surface. I right click on it, then I select create reference. Then for the style, for the style for the surface, I'll only select. I'll set it to border only. And I select OK. So my surface is existing also here. Then I also create shortcuts. I'll create references for the alignment. So I created shortcuts for the Mitiana road. So I'll open, there's a plus sign here, you click on the plus sign here. Then under you see, when you click on the plus sign, you see another plus sign besides the profile. You click on the profile still, then you select, right click on the name of your vertical profile. Then you select create reference. Now you press OK. For styles, I think you can refer to the previous drawing which you worked in for alignment styles. So we have both our surface and alignment in this drawing. So now we are going to create our corridor. We are going to design a road with both a town and a rural cross section. So this last, if you look at the screen, this last region, we are going to design a town section, then afterwards it will be a rural section, until you reach this extreme end where you see still some town cross sections this side, some settlements along the road. So these two sections we are going to design a urban section, like this section where I've selected using this rectangle here. I will support them. Then in between here we shall use a rural cross section. So next we shall create our assemblies. And now why I asked you to use the UK kit, they have some styles for lane marking and also for the shading for the different lanes and the shoulders and the walkways. So on the tool space bar, there is an option for palettes. So you select the tools palette. So you can see when you open this palette here, you can see it has styles for UK and Ireland. It has both the UK, this is for, shows you the coordinate system, the templates, this is their drawing template. Then the typical assemblies in their library, then they have assemblies for junction design. Then these are cross sections for typical interchanges, connector roads, mostly for motorways and expressways here. Then these are for the Republic of Ireland. They have both rural and urban. Then after that you go back to the default assemblies. So we are going to begin by creating an assembly for our town road, our town section. We are going to do a dual lane either side and a walkway either side. Okay. So you select, are we all there? Okay. So you come to this option for DMRB road sections. So, sorry, NRA road sections. This is for Ireland, the one which has it's customized with road markings. This one here. So you select this tab here of NRA road sections. Then for the road section, we are going to create a single carriageway. We are going to select this first option for NRA, hence to single carriageway. Okay, let's take this. So you can see it has brought their default cross-section. I'm going to customize it. And also let's also select another assembly. In the urban there's a list for the rural sections which they have, and also another one for the urban. So let's select this one, NRA urban D2AP. Let's take this last one here for urban motor. We are going to just customize it to a dual carriageway. Yes? This one here, it is NRA urban motorway DU2M. We are going to just customize, use that template and customize it to a typical urban section with 2 lanes either side and a median in between. So let me close this. Now I'll open the properties tab. I'll select my assembly. Open the properties tab. Okay. So you select our assembly. We shall first begin by adjusting our lanes for the euro section. Let's say after the pavement engineer does the design for the pavement, he gives us the different layers of the road, the thickness of the wiring course, the base layer, the sub base, and maybe if it has a capping layer, you also add it. So we are going to just assume a normal cross section. So we shall begin by adjusting the width. For a class 2 paved road, the Our normal close for is 2.5%. So then the normal shoulder width is another table which is supposed to look at specifying the shoulder width, what class of rod. It is here table 4.2 for a class 2 paved road. The lane width is 3.0, number of lanes is 2, then shoulder width is 2 meters either side. So we are going to use, but we shall adjust our lane width to 3.5 meters. This our wiring course is maybe asphalt 50 millimeters, so we shall go with 0.05. Then we have no binder course, so we make this 0. In the base course, let's say it is 200 millimeters, so we shall go with 0.2. Then the sub base, let's say it is also 0.2 millimeters, and it has no capping layer, so we make the depth of the capping layer 0. It cannot shift. We have begun with the one for the row section. When you select it like this, your idea is supposed to be able to edit it. You can edit its parameters from here, from the properties tab. Now we are going to add our shoulders. We are going to delete the default ones from the UK kit. Then you come back to the to the tools palette. Then you come to the palette for shoulders. This one here down. Select it. Then you select shoulders, extend on. So our shoulders for a class 2 paved road, the width is supposed to be 2 meters. It's supposed to be 2 meters width. So we adjust it to 2. Then we are going to make the slope of our daylight here. We first adjust our shoulder slope to 2.5% so that it matches the lane with the lane slope cross slope. Then the daylight slope, we are going to adjust it to 0. In this case, we are going to use what we call conditional sub-assemblies. That is for the daylights. So we shall change the daylight slope to 0. Then afterwards, we adjust the thickness of our pavement layers. Is 0.05 and 0. Base depth we use 0.2. Then the sub base we used 0.2 also. So that's how our assembly looks like. Then afterwards we shall mirror. We select this shoulder we have created.
Could you go back to the thickness?
Okay. You select your shoulder. Then afterwards on the properties tab, you select properties here. Suppose open this dialog here in the design palette. You scroll down. Is where there is The shoulder width we set it to 2. That is from the standards for paved class 2 paved roads. Then we change our cross slope to 2.5%, negative 2.5%. Then we change the slope for our daylight.
There are some people see that issues with data shortcuts. Right? Some people see that issues with data shortcuts. The issue was that when you are getting shortcuts, especially since you're going to be creating a corridor, you find that, remember last time you made a shortcut for alignment?
For the surface, yes.
Then you made alignment, right? Now that is the drawing we are using. Is it possible that you can shortcut the surface that you already shortcut from?
You have to go back to the original drawing.
And now that original drawing doesn't
You don't actually, if you have already created a shortcut, a data shortcut for the surface, you just have to link the new drawing to the shortcuts folder. You can still get the surface into the new drawing.
How about if they continue the same drawing that they are having? Would there be any issues?
Not really, but the idea of using data shortcuts is to have a lighter drawing. Simple 3D drawings are usually very heavy when you're working with them. If you're having everything in one folder, it will be very heavy.
Because some people are still lagging behind because of the shortcut. I was suggesting for those, if they have pieces can work properly, they can equally work with that same drawing, okay?
It's okay.
Okay, fine, thank you.
I was requesting if you can start from the setting of those parameters.
Which parameters?
The width of the rod.
Okay. Have you all opened the UK kit? You open the palettes tab using this icon here. Then afterwards, in the also 3D, it didn't have the UK kits here. These are the UK kits which I've added here. You have to check on the palette. So we are going to use the NRA. These are for Republic of Ireland. They are customized with some markings for lane marking. So we have both the urban and the rural cross sections here. These are typical what they use in their country. So we selected this first one, the NRA, just to single carriageway. So we selected it and we inserted it in our drawing. Then we went to the urban, the NRA, urban D2AP. Then we also inserted it in our drawing. So next what we did, we deleted their shoulders. I think there's a shoulder and a verge. It has a hard shoulder and a verge and a daylight. What I did, I selected this and this, I deleted them. I delete them, then after I go to the tab, on the tool palettes tab, I go to the shoulders tab, then I selected shoulders extend all. Shoulders extend all. It is there on the shoulders. There's on that tab, the tool palettes tab, there's an option for shoulders. Yes. So we click on it, then we select. You can see these circles at the end of your assembly. Here we have deleted the other sub assemblies from it. You click on the upper one, then you insert your shoulder. Then afterwards you can select this since they have the same code sets, they are both lanes. Then you can start adjusting the width, the cross slopes, and also the depth of your pavement layers. So for the lane width it is 3.5. The surface course, we are going to use a wiring course of 0.05 meters. Then we have no binder course, but in case you have it, we insert also its depth. Then our base course layer Let's say we're using also a base course layer of 0.2, then a sub base still of 0.2, and supposing we have no capping layer, so we make this one 0. Then after, I'll do the same thing for the shoulders. Select the shoulder. First we set the shoulder width to 2 meters. That is from the standard for a paved 2 road. Then the cross slope, we set it to 2.5%. Then we set our daylight slope to 0. Since we are going to use what we call conditional sub-assemblies. Then also set the sub-base slope to still the same 2.5. Then also I set our pavement layer depth. We assumed a wearing cost of 0.2, 0.05 meters, that is 50 millimeters. Then a base layer of 200 millimeters and a sub base of 200 millimeters. So this is where it stopped.
Excuse me. So when I place my assembly with the rural carriageway, the carriageway in the middle disappears and what remains are the shoulders and the back.
That is because we are not using the UK kit.
That's what I'm using.
So if you select, anyway, you select this whatever the attachment, where there is crown, then you go to on the properties tab. This is where we have data. Then on the data is under data is what we call the code set style, and you set this to assembly creation. In the drop down you select assembly creation. They should be able to appear. So afterwards, let me delete one of them. Let me delete this one here. So I'm going to mirror my shoulder since it's going to be the same width to the opposite side. So I select my shoulder. Then here on the modify sub-assembly, there is an option for copy, move, and mirror. So I select mirror. Then I move to the opposite side. This upper circle here, I click on it. It will mirror to the opposite side. So you have shoulders on either side of the road. Then afterwards, we are going to do our conditional sub-assemblies. So you right click on this. Just wait. Down here, there are more palettes for many sub-assemblies, including the one for conditional sub-assembly. So you right click here, and it brings up a list. We select conditional. So you select that. So it will open up this conditional cut or fill. So you select the first option for conditional cut or fill. Then we click on our assembly, the attachment point for the next sub-assembly on our cross section, which is this upper part. So we shall insert. We first insert one for cut. We are using this because for different cut heights or fill heights, means if the cut is exceeding 3 meters, we insert a dish. We can insert another dish above to trap the water so it doesn't flow towards the road. I think if you like move along the expressway, you can see such ditches along the road before we start ditches up before we reach actually the road down. So let's do one, but in this case we may not have many high cuts or high fills. So You see on this palette for sub-assemblies, down here, is where you can see there are more palettes down here which you can't see. So you right click here, down, then you go to, in this list you select conditional. Then after you select conditional, cut or fill. So you select the conditional sub-assembly you have added. Then for the layout width, we adjust this to like 8. Then the layout gradient, this one you can, depends on which one, whichever you choose. You can leave it as 1 to 1. Then the type, it is cut. Let's assume for a cut of 0 to, a cut depth of 0 to 1 meter, we are going to have we are going to use a daylight slope of 1 to 1.5, and exceeding 1 meter we have a daylight slope of 1 in 1. So you can say minimum distance is 0, then the maximum. So for a cut of 0 to 1 meter, we are going to have, I'm going to add the sub-assemblies for the daylight for 1 meter, for 1 in 1.5, then exceeding 1 meter we shall add the daylight assembly for a side slope of 1 in 1. So we first add other conditional sub-assemblies. So I still do the same thing. So in this case, so you don't overlap with the first one, we select the new one you have created. Then we change our layout width still to like 9. In our gradient layout, we can change it to 1 to 3, so they don't overlap with the first one. And here the minimum distance will be from 1 up to wherever the cut will end. Maybe 1 up to maybe 10 meters also. So I put like up to almost 10,000. Doesn't matter. So we also add the conditions for fill. Still do the same thing. We insert it at the same point. So in this case, we select this and first change our layout width to like 9. Gradient, you can leave it the same. Then in this case, for a type of condition, we shall change it to fill. And here we can say for a fill of 0 to 2 meters, we shall have the normal side slopes. Then exceeding that 2 meters and beyond, we can insert a guardrail on the side where the fill is high. We insert a guardrail on that side, and also change the slope on over daylight. So we still select the same point. Select that sub-assembly. Change the layout through like 8. And the gradient to like maybe 4 in 1. Then the condition to fill. Then in this case will be from 2 up to more than up to wherever the fill will end. So it will be 20 meters depending. So now we add our daylights on each of these sub-assemblies we have created, these conditional sub-assemblies we have added here. So now we go back to our shoulders tab. We select shoulders, extend all. Now for a cut of 0 to 1 meters, we are going to have a side slope of 1 in 1.5. So we select our shoulder. We change our shoulder width to 0. Then we change this Ideally, it's supposed to connect directly to this point here. That is why I've changed the width to 0, since we have already set our shoulder width to 2 meters. So I change the shoulder width here to 0. Then shoulder slope, I change it to 2.5. Then the daylight slope will be 1.5 to 1. So it changes. Then surface slope still changes to the same. Then you also change our pavement depth. Ideally, the pavement layers are supposed to extend up to the daylight. So that's part is 0.05. We have no binder layer. In the base 0.2. In the sub base also 0.2. So we can just copy this and we change the properties. We select this, copy, and we select the end of each of this sub-assembly. And after, for a cut exceeding 1 meter, let's say we are going to have a side slope of 1 to 1, so we change our side slope, the daylight slope, to 1 to 1, from 1.5 to 1. So we change that to 1 to 1. You can still copy. Also for the fill, do the same. For a fill of 0 to 2 meters, you are going to have the normal cross section. So now what we are going to do, we are going to add our daylight sub-assemblies. So still on this drop down, right click, where are you? This one here. What I did, you have already added these other conditional. These other conditions are more or less like conditions for cut and fill. These ones are also specified in our geometry design manual. Depending on the type or the geotechnical properties of the soils are going to be cutting or filling in. Let me first open actually that page. Down here. I think that's crashed there. I mean, you whatever, CPC. If you are to go to page of the geometric design manual, page 139, they specify back slopes for cut, depending on which type of soil you are dealing with, or rock, depending. Let's say for normal earth or soil, the back slope can be, for cut, can be 1 to 3. This is for the side, 20 the side slope 1 to 4, 1 to 1.5, and 1 to 1, depending. But for these town sections where you're more or less going to be creating a ditch on the side, maybe for the side drain, we are trying to minimize space, so we can go with 1 to 1.5 or 1 to 1. So you stopped here. creating this here. What we did, we are more or less like creating conditions for cut and fill conditions, as we depending on our vertical profile, how we are going to be cutting or filling different areas. So for a cut of 0 to 1 meter, we are going to use a cut slope of 1 to 1.5. That is for lower cuts. Then for cuts exceeding 1 meter and beyond, we are going to use a cut slope of 1 to 1. So that is why I created for a cut of 0 to 1. I'm inserting this condition here. Same condition here. Then for a cut of 1 meter and beyond, I'm inserting another different condition. I did the same for fill. For a fill of 0 to 2 meters. But I think I was still here. I think you can catch up from here. With these ones, I just added a shoulder. Since it's going to attach the shoulder this side, so I added shoulder extend point. Then I made my shoulder width 0. Since I've already specified my shoulder width this side here to be 2 meters, so I set this one to 0, and then I set my side slope, the shoulder, the daylight side slope, to 1 to 1.5. So we are going to add our daylight links, which are going to more or less like project a corridor to the existing ground. So on this, on the tools palette, there's an option for daylight. So you select it. Then we are having quite many here, but we are going to select the daylight standard. So you look for the daylight standard in these options, which is this one here. Select the daylight standard. Then we shall attach it at this point here, at this lower point here. And afterwards, we are going to adjust the properties of this daylight standard, this daylight. So in the properties tab, what we are going to first change we're having many conditions: a flat cut slope, flat cut maximum height, flat cut slope. There are many. Medium, then there is the steep. We are going to first change our forward slope width to something like 0.5. This one depends on the depth of the ditch. Maybe the hydrologist has specified. Yes. It has to be there. Say to plant. So can we continue? Say after the hydrologist maybe has carried out his analysis and he has specified the sizes of side drains, and say the depth of a side drain, say is 0.75 meters deep, the depth 0.75. As a check, you can just draw a polyline attaching it to the center of this point here. Then you offset it downwards. Since this sub-assembly is to scale, you offset it down by 0.75 meters. Then afterwards, you adjust the properties until the depth, the base of our side ditch is at exactly 0.75. So you shall adjust the forward slope width until it reaches 0.75. This depth here. So I'll adjust until I get it exactly where I want it. It has now matched exactly the depth I want. This is 1.15. See. So our depth here is exactly 1.15. Then after we change the side slopes of this is, I'm going to insert a ditch for each of these conditions. So I'll adjust the forward slope, which is this one here, to here we use the forward slope of 1.15. So it will have to match exactly with the slope of our sub assembly here. So I change it to 1.5 to 1. So here it shows I have to adjust till the width of my forward slope. I have to make it less so that it matches the depth I want. It's more or less at that depth. Then I'll adjust the slopes for design conditions depending on where the ground is moving. So I'll adjust my steep cut slope to 1.5 to 1. Then also I'll make sure my medium cut slope is still the same, 1.5 to 1. Then also for the flat cut slope, I'll still do the same. So we are going to ignore this option for fill, since in this condition we are in cut condition. So I'll adjust it so that it matches exactly the slope of this sub-assembly here. So I just make it 1.5 to 1 still. So we are going to just copy this sub-assembly onto the next, for another condition I adjust the slopes here. So I'll just select it, then I come to this option here for modify sub-assembly. I select copy, then I insert it at the slope point here. So in this condition, I will change this to 1 to 1, our cut slope. Let's first change our ditch width to say 0.5 meters. We hadn't changed it yet, so our ditch width we change it to 0.5. So now we change these side slopes now to 1 to 1. Okay. So we begin with the steep cut slope, we change it to 1 to 1. For medium we do the same, and also for the flat cut slope. So it will change to 1 to 1. So now let's proceed to the fill conditions. We select this entire sub-assembly for the daylight where it is. We copy it, we shall begin with a fill of 1 to 2 meters, 0 to 2 meters, still touch that. So in case the ground is, you are filling and the ground is still going in, still sloping in the same direction, to just target the existing, that ground the way it is. But in case you are filling and reach a ground that is moving towards the road, it will cut and insert a ditch at that point. That is why you're having a ditch here. So I think this one remains the way it is. Then for a fill exceeding 2 meters, let's insert a guardrail on that point. So for a fill of exceeding 2 meters, we are going to insert a guardrail. So what I'll do, I'll change this. There's what we call fill widening. From the manual, they specify some parameters for fill widening. Let me open the table. Table 610, the geometric design manual. We have curve widening, that is for sharp curves, and fill widening. So for a fill of 0 to 3 meters, we are going to add the widening of 0.3. Then exceeding 3 meters, you use a fill of, you widen by 0.6 meters. This is for high fills. So let's just use a widening of 0.5 for the shoulders. So I'll make this, the shoulder width is 0.5. Let me change this to 0.5. Then I will also insert a guardrail at this point. So I'll still go down on this drop down. Then there is an option for railings. It's all done. So then for it. It is in the UK sub assemblies. So I'm going for it inside the design. Is what we call a single TCB. This is a guardrail. So we shall select a single-sided guardrail. Then I'll select this point. I'll add it at this point. So it will be inserted at that point by the shoulder. Or I can shift it up to this point here. But let me for illustration purposes, let me leave it there. Then afterwards, I will insert our daylights. I will change this slope to the side slope of the shoulder to, I'll change it to 1 to 1, the daylight slope. And afterwards, I'll add my daylight. I'll copy the sub-assembly from there, insert it at this point. In most cases, this extension they usually make it to be sub-base material, so I can change it actually to be sub-base only. This extension here, the widening. So I'll change the sub-base slope to the sub-base depth to, so that I'm going to remove these thicknesses here. So I'm going to make it 4.5. Going to make my wearing course depth to 0, then the sub base to 0, then this one 0.45, so that we have only the sub base fill at this point here when we are adding our widening. So also change the slopes for the daylight links. I'll change them to 1 to 1. So I think I've finished creating our end conditions. Then afterwards, I'm going to select all of them and I mirror to the opposite side. Select mirror, then I select this point this side. Now we are going to move to our urban sections. It's going to be 2 lanes followed by a curb and gutter, then a walkway. So I'm going to delete these sub-assemblies which are existing. The sides. Yep. I think we are. Man. Okay. So first we are going to adjust our lane width to, let's say we are having 3 meter lanes, not 3.5 in this case. Let's just change them to 3 meters. So I select all lanes and I change the size of the pavement layers and the width of the pavements. I'll change them all at once. So, this is and after I change the lane width, I'll change it to 3 meters. Then let's say we have an raised island here. I'm going to try to create an island at this point. So we shall first insert our curves at these points here. So I'll come to the UK tab for UK design. And I look for their curve. So I insert it at these points here. It's supposed to be or you can just go with the default one because it may take some time to create it from here. So I'm going to delete these ones. Just use the default ones. Let's change the width of the central reserve. Let's change this to, let's say it is a 1 meter island. So I'll change them each to 0.5. Let's say that's our island. And afterwards we can add our daylight. We can add our sidewalks, then the daylight. Change the size of our curb. So if you right click on the British curve to know which dimension you are supposed to change, right click on that sub-assembly, then you go to help. You can be able to know which dimension to change. So in this case, I want to increase the depth of our front link here. So I look at which code it is given. I'm going to just offset the waterline offset to maybe 0.1. And our curve will move up. Okay. So that's our curve. Then we insert our walkway. So we right click here in the UK tab. The design, they have a sidewalk. That option for a sidewalk. So you look for it. Let's go with an option with a detailed footpath. So we insert it at this point here. Let's say we are having our sidewalk has pavers, maybe 0.5 millimeters thick, then a layer of sand, then afterwards you have the subbase layer. So we change these parameters here also. So let's say our walkway is 2 meters. The depth of the surface course depth, we're going to change it to the thickness, say, of the pavers, maybe 0.05. Then the binder layer, let's say it's a sand layer, still maybe 0.03. In a subbase, let's say 0.15. And afterwards we add our end conditions. But in this case, since in most town sections we do less filling, I'm going to just do one end condition, one side slope. For daylight, I'm going to say 1 to 1.5 or 1 to 2. So first I'm going to first insert the edging here, which I insert at the end of the walkway. So I look for it here, is what we call the British edging here, and I add it here. And afterwards I insert my daylight. So I just copy this and I edit it. I'm going to remove this ditch. The idea is we are supposed to add either an open drain here, but we are assuming maybe we are going to have culverts under the walkway. So I'll leave that out. So I'll remove the option for a ditch here. Change my ditch width to 0. Then in the forward slope width, I'll also change it to 0. Let's say that is our side slope. So I'm going to mirror the walkway and the curb to the opposite side. So I select everything and I select mirror from the modified sub-assemblies tab. I select this point here. So we have a walkway either side. So now we have our two sections, the town and the rural section. Let's change their names. We change this to rural section. You select this attachment for the assembly, sub-assemblies, then you go assembly properties. We change the name to rural sections. Yes, okay. And also change the name for the other sub-assembly, Change it to urban sections. And after that, we can create our corridor. So in this case, the limit I'm using, the 00, the starting station is this side. So I begin from here. We had enclosed these regions, this region here, and this region here to be urban sections. So I select my alignment. Then on this tab here for launchpad, I select corridor for creating a corridor. Now name it Mitiana Road. Then I'll select my alignment, which is Mitiana Road. Then my vertical profile, which is still Mitiana Road. Then my assembly, I select the urban section. I'll first way to target the surface. Now press OK. So this dialog we can set the start and end of our sections, the different type of cross sections. So let's assume our first urban section. We select here the start and end chainage. So in end chainage, let's first set our starting point to be here. Then our ending point to be somewhere here. Let's say all this origin is an urban section. Press OK. Then afterwards we insert and the next urban section. So you right click on the first section you have created. Then on the drop down you select insert region after. Then I'll select still my assembly to be urban sections. Then I press OK. Afterwards I select its starting point. I select this side here where it is supposed to start from. So it is beginning from here. Then its ending point. So it ends here. Then afterwards let me first create one for these regions. Let me first set my frequencies. You select set all frequencies. Since we are having some sharp curves, let's change our frequency to like 211 for all of them, along straights and curves, and also along transitions, and also along the vertical baseline. And press OK. And we build our corridor.
Was printing. Was printing. This class.
So it has created our corridors. You can select our corridor. You select our corridor. Then down here you see where we have data. Then code set style. In the drop down, we select plan view solid hatch. So here you can see the different regions of the road, the central reservation, then the two lanes, followed by the curb, the walkway, then the edge beam. These styles are default for the UK and the Ireland standards. You can customize them further. So let's insert our rural region, which is in between these two. So we select the corridor, then you go to, on the modify corridor tab, you go to corridor properties. Then it opens this dialog with information, parameters, codes, and so on. So we go to the parameters tab. Then we select the first section which we created. You right click, insert, and you select insert region after. Then you select the rural sections from the drop down for the assembly. You press OK. And also change its frequency to 1. After I press OK, then afterwards we can set all targets. Let me first try to set all targets for target the surface. I press OK. So at these points where the two regions meet, we have to create transitions for both the lane, the lane width and the shoulder width, since they are varying. So first we shall create offset alignments. One will be corresponding to the width of this median here. Then another one for the lane width, another one for the shoulders.
don't know. I don't.
This is more exactly your heading.
It's the same.
The same as with your heading.
You mean that targeting them?
Yes, that's what we're targeting.
See that what targeting?
Yeah, first create like now here. Now here we can create a no. We stop here because the one is very small.
It's okay.
We begin from your command.
You're going to start from here because now this is where I'm going to be talking about what you need.
Okay.
Let me first do this mouse.
Okay.
Hello? Good evening. How are you all feeling? You remember you all visited YouTube one time and you wanted to learn the software? You visited YouTube at one point and you tried to learn the software, right?
It's true.
So it has been a mix-up, especially from the basics and advanced. Maybe you should have separated them. But it's also a good thing that we are all here. So I first taught a little bit of the basics, which are supposed to be going to the student side, and then you had some professions that were expecting the advanced side. So you have stretched the muscles of the students who are not even familiar on what to draw. Not even, they haven't even seen the user interface, but now they are doing advanced modeling. Yeah, okay, for now, I was requesting, I think we can either agree or agree to disagree that we are retired. Is that correct? Actually, some members have already left. Was supposed to stop some time ago, but I just told him, you just try to push, as long as you still have some recording. Tomorrow is going to be our last day. There's still a little bit of a few things that are very, very vital, rather than even one bit, but there's a lot that we have to cover. So tomorrow, let's be here very early, so that we can catch up. We are going to be continuing with the modeling, just a little bit. Go through it. I'm going to actually stretch the muscles further, so that we cover a lot within a very short period of time. As long as we can keep time in the morning, as long as we are here, okay?
Could you have a copy of this drawing? Because I want to pass
It's okay,
we
share
can
it.
even do it tonight, so that by the time we come tomorrow, at least we have it.
Yeah, honestly, it's only fair enough that we share some of this information today.
Yes.
Okay. I don't know, even with the recordings, it would have been possible. But they are very heavy.
I just the drawing.
The drawing is okay. Some of you guys have followed, right?
Yeah, we have followed.
You have followed. So we are going to put this in the WhatsApp group. I'm sure the drawing is not as big. Unless if there are some issues with the drawing. Because sometimes you can import a new drawing and there are no references. Yeah, so we are going to share the drawing effective immediately. Perhaps, if possible, we can also share. Maybe